Hi friends, today I am going to see about transpose of a matrix. Transpose, how to find means we have to interchange the rows and columns. So consider example A. Here the number of rows are 2 and number of columns is 3. Now how to write a transpose for this matrix means the notation to denote the transpose is A par T, that is A transpose, or you can indicate it by A dash. We can use A transpose as A par T or A dash. And now we have to interchange the rows and column. So first row you are writing as a column. So 1, 2, 3 are the elements that you have to write as a column. So 1, 2, 3. The second row. So 4, 5, 6 you have to write as a second column. So 4, 5, 6. Now what is the order of the matrix A? Number of rows into number of columns. So the order here is 2 cross 3. Now for transpose the order is 3 cross 2. Just you have to interchange the rows and columns. Next we are going to see some properties on transpose. There are 4 properties are there. First one is A transpose, the whole transpose is equal to A. For a matrix, if you take 2 times transpose means you will get a same matrix. The next, with a scalar multiplication, Ka the whole transpose is equal to K into A transpose. The next, for addition and subtraction, how the transpose is applied means A plus or minus B the whole transpose is equal to A transpose plus or minus B transpose. For product, the transpose is applied in the reverse way. So AB the whole transpose is equal to B transpose into A transpose. Using some examples, we are going to see all the properties. Now consider this example. Here I have taken a matrix A as a 2 cross 3 matrix. Now we are going to take a transpose for this. How to take a transpose? Interchange the rows and columns. So first row we are writing as a first column. So 1, 0, 1. The next second row as a second column. Now what is the order of A dash? 3 cross 2. Now again I am going to take a transpose for this A dash. So again we have to interchange the rows and columns of the transpose A. So first column I am going to write as a first row, second column as a second row. Now compare this matrix with your A matrix. It is similar to your A matrix. That is the first property we have seen. A double transpose is equal to A matrix. Next we are going to prove the second property. Ka the whole transpose is equal to K into A transpose. As I said, K is any constant. Here I have taken a constant as 2. So we are going to prove the property 2 times A the whole transpose is equal to 2 into A transpose. Consider the matrix A as 1, 0, 2, minus 1. Now left hand side we are going to find. So 2 times A. What we have to do? Multiply 2 with all the entries of A matrix. So we are multiplying the matrix A by 2. So the entry are 2, 0, 4, minus 2. Now for this 2A you have to take a transpose. So transpose means just interchange the rows and columns. So I am taking this row as a column. Then second row as a second column. So this is the value for 2A dash. Now this is your right hand side. So take it as a equation 1. Next A dash we are going to find. So A dash means for A matrix you are taking a transpose. So first row I am going to write as a column. So 1, 0. Second row as the second column. So the value of A dash is 1, 2, 0, minus 1. Now what is your right hand side? 2 times A dash. So with this A dash you have to multiply 2. So 2A dash is equal to, just multiply each entry by 2. So it becomes 2, 4, 0, minus 2. And now compare this with your first equation. The entries are same. So what we are going to conclude means 2A the whole transpose is equal to 2 times A transpose. Hence we proved the second property. Next we are going to prove the third property. For addition and subtraction, A plus or minus B the whole transpose is equal to A transpose plus or minus B transpose. Here I am going to prove for addition. The same case we are going to have it for a subtraction also. So consider a 2 matrix A and B. To do addition, what condition should be there? It should be of same order. So I have taken a A and B matrix as a square matrix of order 2. Now we are adding the matrix A and B. So corresponding entries has to be added. Already these things we have seen in last video. So while adding the matrix A and B, we are obtaining a matrix as 3, 1, 2, minus 2. Our left hand side is A plus B the whole transpose. So for this addition matrix, we have to take a transpose. So I am taking a transpose for the obtained matrix. Now take a transpose for this. So the first row has to be written as a first column and the second row as a second column. So this is your left hand side, consider as equation 1. Now we need to prove the right hand side. So we have to find A dash and B dash. So we have find out the A dash, just interchange the rows and column. So first row you written as first column, second row as second column. Similarly for B, we have written B dash here. Now we have to add A transpose with B transpose. Now we are adding the 2 transpose matrix so that you are obtaining a matrix as 3, 2, 1, minus 2. Now compare 1 and 2, both are the right hand side are equal. So we can equate the left hand side. By that we are getting A plus B the whole transpose is equal to A transpose plus B transpose. Similarly the subtractions also we can prove it. Next we are going to prove the fourth property, product transpose. So AB the whole transpose is equal to B transpose into A transpose. So I have taken a 2 matrix A and B. A is of order 2 cross 2 and B is of order 2 cross 1. As we have already seen, to do a product, the condition is the number of column of the first matrix should be equal with the number of rows of the second matrix. Here the column matrix for the first one is 2 and the row matrix of the second matrix is 2. So they are in a equal value. So we can do a product of AB. Now we are finding the product matrix of AB using a row column operation. So first row you have to consider and multiply with the first column. Now 1 into 2 plus 1 into 0 into minus 1. That will give the first element A11. Then next there is no other column. So you have to pass on to the second row. So take the second row and multiply with the first column. It will give the A21 element. So minus 1 with 2 plus 2 into minus 1. So its answer is minus 4. Already we have seen the product calculation in the last video. So you can refer that. Now the obtained matrix is of the order 2 cross 1. The remaining part will be the order for the resulting matrix. So the order is 2 cross 1. Now what property we have to prove? AB the whole transpose. So for the product matrix we have to take a transpose. So take a transpose for the obtained matrix. The column matrix has to be written as a row matrix. Now its order is 1 cross 2. Take it as a first equation. Next we are going to prove the right hand side. So the right hand side term is B dash into A dash. So we have find out the transpose of A matrix and B matrix. Now to do a product, the first matrix here is B dash and the second matrix is A dash. So condition whether it is satisfying or not, you have to check it. So the first matrix column should be equal to the number of rows of the second matrix. Here B dash, what is the column of B dash? 2. And for A dash the row is 2. So they are in equal in value. So we can do the product for B dash and A dash. Now we are finding the B dash into A dash by using the row column operation. Consider the first row and first column, do the multiplication. So 2 into 1 plus minus 1 into 0. That will give the first entry A11. The next first row we have to consider with the second column. So A12 position will be there. So that is has to be written in the A12 place. So 2 into minus 1 plus minus 1 into 2. Then next simplified value is 2 minus 4. Now this is your matrix B dash A dash. Now compare this with your first equation. That also 2 and minus 4. So left hand side and right hand side are equal. So by that we are proved AB the whole transpose is equal to B transpose into A transpose. Thank you friends. Hope you have understand the transpose of a matrix concept. Next video we will see with another topic.